I'm going to walk you through different flavors of platform, like what do people mean when they call they are building a data platform. One specific example of how a data platform looks like, what quality means to a data platform, and what are the unique challenges you have while you QA a data platform versus you QA other projects. When people build a data platform, they can build it for one of these use cases. They can build a data platform to make a queuing system where data sources can write to a pool and data consumers can read from them, and they can be perfectly decoupled from each other. The next use case is reacting to events, like where we process data, like we get data real time, manipulate data, and then we try to provide that data as a service to a downstream system. And the third case is not very well known as the first two, is using a data platform as a reliable event source. So companies like Airbnb and Amadeus, they use it. A very well-known application of using a data platform as an event source is Git, where all the events are captured and all the truth about the events are captured. And at any point in time, one can go back in time and recreate whatever has happened in the past. Depending on for which use case a data platform is built, it has to have a few characteristics. So if we, for example, New York Times were building a data platform using, say, Kafka, they have a number of data sources writing to them, and they instantly push the feeds that they get back to their users. And in this case, availability is really important. And the log of events is not as important as it would be for something like a Git or any event-based system. And the second is when you want to react to data. This is the well-known use case of stream processing. Some other application, like some other aspect of your cluster to make sure that it makes the entire system available, wherein while processing a stream, you're more worried about your responsiveness and the accuracy of the results that you produce. The third case is if you want to use a data platform like Kafka as an event source, where you want to create a reliable data source which is perfectly replicated across clusters, and you can at any point in time read the data and replay or recreate whatever had happened in the past, then you're more worried about data integrity and you're not worried about availability. I'm going to talk to you about a project that we did, which meant we had to apply two use cases, which was events like stream processing and using Kafka as an event source. The high-level architecture, it looks something like this. So you have a data source, and you have a REST API that writes data into Kafka. At a very high level, for this session, let's assume Kafka is a data store, and let's say Zookeeper is something that manages how data is written into this data store. And then there is a schema registry, which makes sure that a number of data sources, a variety of media can write to your data platform. And at any point in time, you can process data you can reprocess data that is already in your system. And then you have a streaming application, a Kafka that's built with Kafka streams. So you have user visits, and you see people buying stuff, and you apply your stream to to make some logic, manipulate the event that reached you, and then sync it somewhere. We clearly know on the use case for which we develop a data source. And we have decided on the technology on which to build a data platform. But once the decision is made on the tech architecture, this is how, assuming that the platform is built for the first time, this is how a platform evolves. So this one use case, which if successful, would drive adoption across the organization, then becomes a measure of success. When I call this application the alpha application. So while we build the data platform, we prove that this one application is able to do what it, to solve the problem, and that will prove the success of the project. My responsibility as a QA in any team is to make sure that I can validate what is being developed, verify that it is right for the user, and making sure that I can accelerate project delivery in a way, faster than a project would go without a QA. So these are like three things which I hold close to my heart. And I will walk you through how these three aspects of QAing a platform are different in a data platform. So as you can see, like anything that you see in light green is an attribute of a data platform, and anything that you see in light blue is an attribute of an app. So this app is built on a data platform, say on Kafka or Kinesis, or some other stream. And the platform has some attributes. So see the attributes that you see in these small circles on the outside. So you may recognize that these terms, they are heavily borrowed from the world of big data. So you can see at the top, you can see velocity, like how quickly your system reacts. Veracity is making sure that your data, there is data integrity in your system. Volume, ability to handle load. Variety is being able to handle different types of media. A typical day for me is making these loops again and again, over and over again, in the direction of these arrows, testing the platform and the application together. If you're used to an infrastructure team handing over some piece of infrastructure and you built an application on top of it, most of the time you don't have to worry about the infrastructure because infrastructure is dumb. Whereas when we talk about data platforms, we are talking about platforms that behave differently based on the use case you are building it for. So this is the same picture we saw earlier, which shows that quality happens at two layers, one at the platform and next at the app. I will try and demonstrate this with two specific examples. And this is like a simplified version of what you saw earlier. Like the high-level architecture is oversimplified to be like this. So you have a data source, some sort of a connector that pulls in data from a data source. And then you have Kafka. Consider Kafka as a database for the simplicity of the discussion. And you have Zookeeper that manages Kafka. And then you have schema registry that knows about all the schema of data that's ever returned to the cluster. At this point, you enter the application side, where you have the Kafka stream application and a sink. So logically, there are two layers. And if one were testing for a data integrity, there are several places that an issue for data integrity can occur. A duplicate data occurrence can occur in your data platform if there was a problem with a connector. In our case, we used Kafka Connect, which makes sure that any changes to a database, like change track is change tracked and is pushed to Kafka. A challenge to data integrity can occur at another level, at the streaming application. To make sure that the cluster is responsive, certain configs in the streaming application are changed such that the stream processing can happen quickly. Like it does not have to make a reference too often. And this means that the accuracy of the data that you provide to a downstream system is necessarily not right. The challenge to performance can occur at 2 layers, like you can see. In this case, it occurs in 2 layers and it happens at 3 places. It can occur at a connector level. So the way Kafka works and like the way the Kafka connectors work, we found that they do not work very well in the distributed mode behind a load balancer. So which means that you straight away have a bottleneck to your platform. For the sake of accuracy, we always want to look up against the latest reference data, which means like we keep refreshing the reference data, say every 3 milliseconds, which means the stream process can be really slow. So which means the process of your entire application is not just in one place, but it is at the mercy of so many components in your cluster. Once you have an entire cluster up and running, and it is processing data, and you know that it's functionally up and running. So at this point, if you start thinking about your path to production, I mean, you prove the accuracy of the system. Like you put 1 million records through the system, and these 1 million records are carefully chosen to represent your real-time data, and you exactly know how you want them to react, and then you do a data reconciliation to see how accurate your results were. It forcefully introduces you to the replay situations where Kafka streams, they react instantly based on what business logic you apply to them. And say, for example, there is a wrongly priced item which is sold for like 20 minutes, and now a new price needs to be applied for all the transactions, or a refund needs to be processed for so many transactions because there was an error. So this introduces, like, running a volume test forces you to think about a replay situation where where you have to go and restore a set of data back in time, reprocess, and make the system good again. These volume tests, they exposed problems in the configs that we used. We were compromising on accuracy, and then we quickly understood that if we were doing a dynamic pricing application, then we realized by running the volume test that we needed to change these stream configs to look up against the latest reference data, like some reference which is refreshed. And it also helped us discover problems about CPU utilization, which we could not have found earlier. Validation, according to me, is making sure that the right things are getting built, and also making sure that when you have two right things which are getting built, the one of the most business value gets built first. Everyone sees the alpha application. Everyone, say you're building an application to dynamically price in something on a website. So everybody sees this business layer, and no one sees the platform that enables these functions. There is a clash of platform and app features. So there is constant competition in this space to have more and more features, whereas it's very clear to the team developing it that the platform needs to be solidified. What we learned with regards to validation is that it's very important to define what success is for a platform and what success is for the application. To get rid of this problem of having a clash between the platform and app features, we understood we had to very clearly articulate the business value of each story that is built towards the platform. So the third thing I do as a QA is accelerate software delivery. This is something that most of the QAs, they already follow. So when we started about thinking a test strategy, like we thought about having a number of unit tests at the bottom, component tests, integration tests, and E2E tests, end-to-end tests. And it is understood that as you go up on the pyramid, it's costly, it's hard to maintain, so have as little as possible on the top and have more tests at the bottom. So, but what we ended up doing is this, where I know it's an anti-pattern, but the end-to-end tests actually helped us understand the cluster, and we complemented it with a slim layer of integration tests. So when I say the end-to-end tests were more useful, I can say it in other words that the components in Kafka, or like the components in a cluster, integrated very well with each other, and it seemed to have been very well tested by the providers of the platform. And then we quickly understood that end-to-end tests fed back to us so much that we decided to run these as part of our deployment pipeline. So as and when a component in the cluster gets built and deployed, this gets tested end-to-end with the rest of the living components, thereby making sure that at any point in time, the cluster is always happy. The cluster is always happy means that the application can then perform sensible tests on top and make sure that they only see proper failures or successes. So these are the two things how end-to-end test helped us. One, it always gave us a sense of the degree of stability of our cluster. And because to start with, we did not understand this beast called Kafka, Zookeeper, schema registry. So this helped us eliminate the problems in the cluster one by one. When you build a platform, maybe introduce one component at a time, you may be tempted to go for the entire stack, but make sure you introduce one component at a time. Make sure that it integrates with the rest of the components which are already up, and supplement your end-to-end and integration tests with lots of health checks and monitoring. And if I were to summarize the whole experience, I would say we started putting this cluster, this ugly mammoth, into a weight loss program, and then we ended up in a healthy elephant. Yeah, so that's everything I have today. This is what I covered. If you have any questions, please ask.